PERI Vario Tension Proof. The wall formwork system with the tried and tested GT24 Girder. Vario means application to different types of project, layout, and concreting height up to 18 meters in one piece. The continuously adjustable Vario slot principle ensures a panel connection that withstands tension and compression and gives a regular joint pattern. A few blows of the hammer on the wedges make it flush, aligned and grout tight in a single operation. From bridge abutments, through multi-story buildings, complicated column cross-sections, to simple, straight walls, whether in the form of single-sided or climbing formwork, Vario Tension Proof always offers the right solution. Vario Tension Proof, the modular girder wall formwork. The standard components of the system, steel wailing, GT24 girder and hook straps, can be assembled into formwork customized for a particular project and site. We will be showing you how to construct the assembly platform, basic assembly of the Vario panels, and formwork erection with the Vario system. PERI supplies special panel assembly tools and machines such as an impact wrench, power screwdriver, for plywood screws and drill bit. You will also need a hammer, 4 G-clamps, a drill, a square. A flat level assembly platform strong enough to allow nailing is required for basic assembly of the Vario panels. Its length and breadth should be about 1 meter greater than the biggest panel to be assembled on it. In this example, the platform is 3.75 meters wide by 5 meters long. A board is now fixed on its shorter side for aligning the ends of the girders. A plywood batten is fixed to the platform to enable the board to be secured. The prefabricated 330 mm high girder alignment board is then fitted. After being set against the batten, it is plumbed with the aid of a square and screwed tight. A strip of plywood for aligning the ends of the steel wailings is fixed along the longer side of the assembly platform. To fix it exactly at right angle to the girder alignment board, the angle is set out with a measuring tape, using a triangle with sides in the ratio of 3 to 4 to 5. Starting from the corner, 3 meters is measured in one direction, and 4 meters in the other. The diagonal between these 2 points must then be 5 meters. Align the wailing alignment strip with this point and fix it. The 50 by 200 mm centering pieces for the steel wailings are now fixed. 2 are needed for each wailing. The dimensions for the centering pieces as shown on the assembly drawing can now be transferred. It's very important to position the steel wailing accurately since, as you will see later, the panels cannot otherwise be connected properly with the Vario coupling. The maximum spacings in PERI's book of tables must not be exceeded when designing on-site. Templates are now fixed on the platform to locate the girders in the right position. 2 are always needed for each size of panel. For standard panels, 2.44 meters wide, 2 timbers 2.39 meters long and 14 spaces are cut. The timbers are the same length as a steel wailing. The girder spacings are marked on the timbers as shown on the assembly drawing. You should always work with pairs. The first spacer is fixed 93 millimeters away from the edge. The others can now be laid on the marks and screwed down. Here again, the maximum spacings in PERI's Book of Tables must not be exceeded when designing on site. At the top and bottom of the panel, the girder spacing timbers are laid on the platform and fixed. As you will see later, accurate spacing of the girders is particularly important for extension of the elements. Once the platform has been completed, a start can be made on assembling the actual panels. The steel wailings are laid on the platform first. 2 people are needed. Ensure the steel wailings are laid hard up against the alignment strip. In the case of steel wailings without end plates, it must be ensured that the slot notch faces towards the girder, that is, upwards. The last steel wailing is laid in position. The edge girders are then positioned. Lay the GT24 girders on top and ensure they are hard up against the end plate of the steel wailing and the alignment board. The GT24 is secured against slipping with G-clamps. The girders are fixed with a coach screw first, which pulls them up to the end plate before they are finally connected to the steel wail with a girder claw. The remaining girders are laid in position and connected. All of the GT24s must be pushed hard up against the alignment board. The hook straps are simply threaded through the latticework of the GT24, slipped onto the flange of the steel wailing, and screwed tight with the impact wrench. They must be tightened alternately to ensure even contact pressure. Once all of the hook straps have been tightened, fitting of the form lining can start. The first sheet of plywood is laid and aligned to project 27 millimeters beyond the bottom of the girder. It must project evenly on the sides, about 38 millimeters. The sheet is fixed in this position with 2 nails. Put the remaining sheets on and align them. Check the side projection again and correct if necessary. Any cut edges of the sheets must be treated with sealing varnish or something similar to prevent water penetrating. Once all of the sheets have been placed and aligned, the bottom one must be fixed first with 2 screws. Now compress the joints between the sheets with G-clamps so that they are tight, and then screw the sheets down. A template with all the screw positions marked is produced for this. This screw template is laid on the plywood. The screws are now started with a hammer. The depth stop must be set before they can be screwed in with a power screwdriver. This is important to avoid damaging the form lining. The head of the screw must only lie on the form lining and not penetrate too deeply. Otherwise, there will be a raised impression on the surface of the concrete, which will require expensive cosmetics. About 10 screws are required per square meter of formwork. The tie holes are now drilled. A tie hole gauge is produced to make work easier. The marks correspond to the spacing of the steel wailings over the height of the panel. With the standard panel width of 2.44 meters, 610 millimeters is measured from the edge of the panel. The tie holes are drilled with a bit. In the case of special elements, watch out for GT24 girders and hook straps underneath. Like the cut edges, the bores of the holes must be protected with sealing varnish to prevent water penetrating. When designing on site, the maximum tie spacings are found in PERI's Book of Tables. When used with PERI climbing scaffolds, the holes for the advancing anchors must also be drilled. After the formwork has been removed from the platform, the plywood protection timber is nailed on. The standard panel is finished. Support timbers are positioned and the steel wailings laid on top for assembling vario panels. Support timbers 800 millimeters long, 120 wide and 200 deep are fixed. After being set out, the centering pieces are screwed on. The vario steel wailings are now laid on and aligned. There are two vario elements. The vario VEL panel with the corner on the left and the vario VER panel with the corner on the right, seen from behind and above. The girder must now be mounted on the short leg of the vario steel wailing. To achieve this, insert the GT24 with pre-inserted hook straps. Align and hold in position with G-clamps. The hook straps are again tightened alternately. The pair of girders for the vario corner are now prepared. It's essential to clean used materials thoroughly beforehand. Lay the two girders in the right position next to the vario steel wailings on the assembly platform. The packing timbers, exactly 80 millimeters deep and 230 millimeters long, are now nailed on at a maximum spacing of 600 millimeters. It's essential to keep the area of the steel wailings clear to avoid hindering subsequent assembly. The two GT24s with the back facing up are now stood up and held together with G-clamps. Allowing for the position of steel wailings, the approximately 220 millimeter wide strips of plywood are screwed onto the back of the girders. Now lay the pair of girders on the steel wailings. Push against the end alignment board and clamp with G-clamps. They're connected with one fixed strap and two diagonally positioned coach screws per vario steel walling. Now, as with the standard panel, the edge girders and the intermediate girders are positioned. With a smaller number of panels, the intermediate girders are set out. For larger quantities, a girder spacing template must be made. The remaining girders are positioned, aligned, and connected to the steel wailing with hook straps. The right angle in the corner section must be checked again before the plywood is fitted. The first sheet is laid on the girders and aligned at the bottom edge of the girder like the standard panels. With the aid of strips of plywood tacked on beforehand, the projection needed for the side plywood is adjusted and fixed with two nails. The remaining sheets are now laid, aligned, and screwed on. The side plywood with the standard width of 480 millimeters is now fitted. The plywood is positioned, held with G-clamps, and fixed with plywood screws. The tie holes are now drilled. The standard hole for a 1.22 meter wide element is right in the middle. This means measuring 610 millimeters from one side. Drill the holes with the bit, then seal the balls. After the panel has been removed from the platform, the plywood protection timber can be fitted. This completes assembly of the panel. In the following section, you will see how formwork erection can be carried out quickly, reliably, and cost-effectively with Vario. The crane splice 24 is used for lifting the Vario panel safely and easily with a crane. Follow the instructions for use of this unit, which include important application details, such as the safe working load. The Vario 99 coupling and 4 tension-proof wedges are required for the standard panel connection. The panel is aligned roughly to start with. When using the Vario coupling, it is essential to ensure that the slot notch faces towards the concrete. The coupling is centered with a wedge. Initially, the first wedge is inserted into the first slot on one side. 4 holes must remain empty, so the second wedge is inserted into the 5th hole. The centering wedge is now removed and inserted into the first hole on the other side as the third wedge, and hammered in until the form lining joint is tight. The 4th wedge locks the joint. This makes the panel connection resistant to tension and compression. The articulated coupling is used for forming angles. Ensure that the slot notches face towards the concrete in this case as well. When inserting the tension-proof wedges, again ensure they are locked so that the panel joint resists tension and compression. To achieve any construction dimension with a 2-panel width of 2.44 and 1.22 meters, any infill up to 1.22 meters can be introduced with the continuously variable Vario coupling. To make the filler panel, the plywood is first cut to size and then the GT24 girders laid out. Their spacing must not exceed that of the panels. Lay the form lining on the girders so that it projects about 25 millimeters. Once the form lining has been screwed down, the filler panel is turned over and the coupling compression plates set out. The distance between the centers of these plates corresponds to the spacing of the steel wailings. They're screwed on with 8x60 coach screws. The filler panel should be guided as it is lowered into place. A quick push on the form lining brings the panel into the right position. The panels are connected quickly with the Vario coupling. Knock the tension-proof wedges in loosely to center roughly. The filler panel is pulled flush with the K wedges. The effect is clearly evident from the form lining side. Hammering the tension-proof wedges in tight makes the panel connection resistant to tension and compression. The standard panels must always be positioned accurately in relation to each other. The necessary infill is added to the external face with a filler panel. The width of this panel is equal to the thickness of the wall. When assembling the filler panel, allow the outside girder to project about 20 millimeters. As you will soon see, this achieves a grout-tight outside corner. The pre-assembled filler panel is now connected to the standard panel on the platform. To achieve this, the vario coupling is laid in position. The K-wedge is hammered in, and the joint pulled tight with the tension-proof wedges. The panels are now assembled at the outside corner with the form lining of the standard panel resting on the filler panel's edge girder, which projects 2 centimeters. And now to clamp the corner. A tie yoke is attached on both sides. Here again, simply using a hammer and a tension-proof wedge. The wing nuts are tightened to complete this operation. With vario column formwork, it is advisable to hammer the tension-proof wedges in again firmly. This leads to an even tighter joint. Push-pull props and kicker braces must be connected to allow the formwork to be plumbed and transfer wind forces. The length of the prop depends on the height of the formwork. A simple rule of thumb is to say that the length of the prop equals the height of the formwork. PERI offers various types of push-pull prop and kicker braces in lengths up to 10 meters. Push-pull props and kicker braces can be connected to the formwork in 2 ways. Either to the GT24 with a girder headpiece, or to the steel wailing with a wedge headpiece and K-wedge. The push-pull props are connected with a pin. They are held down on the slab by means of the base plate and expanding bolt, for example, dowels. After the reinforcement has been fixed, the ties are fitted. PERI supplies the following formwork tie equipment and accessories: DW15 tie rods, wing nut pivot plates, spacers, tie rod spanner. PERI manufactures various tie systems for normal and watertight walls. The tie rods mounted with the wing nut pivot plate are inserted from the back of the formwork. The spacers, which have been cut to length, can be slipped on. The inside formwork is now erected. It is always started with the vario panel from the corner. As you have already seen from the assembly operations, account must be taken here of whether you need a right or left-hand panel. The crane must continue to hold the vario panel in position until it is safely connected to the outside formwork with formwork ties. The filler panel is now fitted between the short leg of the vario panel and the following standard element already positioned. The 147 or 211 vario coupling is inserted and the panel connected with the wedges. The inside corner is completed with the ties. The following panels are erected in the same way, connected with vario couplings and tied. Using the tie rod spanner, one person can tighten the ties without the need for assistance on the opposite side. The stop end is now fitted. This requires the following parts: stop end splice, tension-proof wedges, tie rod, wing nut pivot plate. The stop end panel is stood up and pushed against a restraining batten. The stop end splice is inserted and secured with 2 tension-proof wedges. The tie rod is screwed in. The stop end panel is fixed with a wing nut pivot plate. The stop end at the other end of the formwork is connected in the same way. The GB80 scaffold bracket is used to assemble a concreting platform. The permissible loading width is 1.22 meters. The maximum imposed load, 150 kilograms per square meter. The scaffold brackets can be mounted with a panel lying flat, which is simpler and safer, or with a panel upright. Mount the GB80 scaffold bracket and secure with a captive safety pin to prevent it being removed accidentally. Lay boards of a suitable length and secure to prevent them being removed. Insert handrail boards and nail on. Finished. The side handrail must always be fitted to the end panel. Clamp 2 handrail holders in position, insert short handrail boards and nail on. The extension splice 24 is used to extend the Vario panels. Lay out the panels to be extended on a flat surface. Align and fit the number of extension splices needed according to PERI's details. A panel connection using a 24 extension splice has sufficient flexural stiffness to allow panel units up to 8 meters high to be lifted in one piece. Striking starts with the releasing of the ties. Always only remove those that are necessary to move a unit. For safety reasons, the panel must be supported by the crane before the top restraining point, where the tie or coupling is released. The wedges are now released and the coupling pushed into a panel laterally. It is secured against falling out with the wedges. This approach makes shuttering more efficient, since all of the small parts remain on the panel. Once all of the connections have been released, the panel is lifted to the next location in which it is to be used. PERI recommends the use of the environment-friendly concrete release agent BioClean before using the formwork for the first time and each subsequent time. PERI Vario Tension Proof B-Wall Formwork System.